Far beyond the warmth of the inner solar system, where sunlight fades into starlight, lies a lonely blue world, Neptune. At nearly 3 billion miles from the Sun, Neptune orbits in deep cosmic twilight. Cold, remote, silent. Or so we thought. Something was happening, something invisible to our eyes, hidden in Neptune's strange skies. A mysterious glow flickered softly across its atmosphere, invisible for decades. A spectral aurora, not like the ones we know on Earth, but a faint, displaced light far from the planet's poles. And finally, after 30 years of searching, humanity has seen it, with the infrared eyes of the most powerful telescope we've ever built. This is the story of Neptune's hidden auroras, a cosmic secret unveiled by the James Webb Space Telescope. In the most remote corners of our solar system, 2.8 billion miles from the Sun, a lonely blue world drifts in darkness. Neptune, cold, distant, mysterious, was long thought to slumber in silence. Yet something was happening deep within its twilight sky. A ghostly glow flickers against its azure hue, forming an unseen play of light where previously nothing had been observed. This is the story of Neptune's hidden auroras, a cosmic mystery now uncovered by humanity's newest celestial eye. We begin in the darkness that envelops Neptune. From here, the Sun is a faint speck, 30 times farther away than it is from Earth, casting little warmth. And yet atop the clouds of this icy giant, there is a strange auroral glow. Unlike the familiar auroras on Earth, bright curtains of green and red that ripple across the polar skies, Neptune's aurora defies expectations. Rather than appearing at the poles, it shines closer to the mid-regions. A glowing blue haze wraps around the southern latitudes of the ice giant, roughly where South America would lie on a globe. This is an aurora exiled from the pole, a quiet signature of Neptune's uniqueness. For decades, this glow evaded detection. Telescopes strained for signs of auroral activity but found nothing. Only now, with the unparalleled infrared vision of the James Webb Space Telescope, have these elusive lights finally been seen. This discovery opens a window into the forces shaping Neptune's atmosphere, its magnetism, and its internal energy. But to understand what Webb found, we must return to the first hints of Neptune's auroral mystery. In 1989, after a 12-year journey, NASA's Voyager 2 spacecraft arrived at Neptune, the first and only spacecraft ever to visit. In a brief flyby, Voyager 2 transformed a distant blue dot into a world of astonishing surprises. It discovered faint rings encircling the planet, geysers of nitrogen erupting from the moon Triton, and an atmosphere of turbulence and ferocity, with the fastest winds in the solar system, more than 1,300 miles per hour. Voyager also made a puzzling discovery. Neptune's magnetic field was wildly misaligned. Unlike Earth's relatively upright magnetic axis, Neptune's was tilted 47 degrees from its rotation axis. Stranger still, its magnetic center was offset from the planetary core. This meant that magnetic poles and geographic poles didn't align, an anomaly that suggested auroras might appear in unexpected places. Yet Voyager could detect only the faintest signs of auroral activity. Brief bursts of ultraviolet energy on the night side of the planet, a whisper of a phenomenon that theory insisted must be there. After Voyager's departure, Neptune once again faded into cosmic obscurity. Still, scientists kept searching. Though frigid and distant, Neptune emits more than twice the heat it receives from the Sun. An internal energy source drives storms and feeds powerful winds. Combined with its unusual magnetic field, many believe this energy might generate auroras, triggered by solar wind particles or material from Neptune's system. For over 30 years, astronomers pursued this theory, night after night, studying Neptune's light spectrum. The results? Nothing. At Neptune's distance, auroras are faint, and its upper atmosphere was thought to be too hot, around 809 degrees Fahrenheit. High temperatures usually mean bright auroras, but none appeared. The mystery deepened. Only a leap in technology could break the silence. That leap came in 2021, with the launch of the James Webb Space Telescope. In 2023, Webb turned its gaze to Neptune, unknowingly poised to end a decades-long search. Side-by-side images revealed the transformation. On the left, a serene blue Neptune captured by Hubble. On the right, the same view enhanced with Webb's infrared vision. Suddenly, Neptune wasn't serene, it was glowing. Blue spots appeared on its disk. These were auroras, at last captured in direct images. Unlike the uniform blue of visible light, the infrared image revealed glowing regions in the mid-latitudes, far from where anyone expected. The data behind this discovery came from observations in June 2023 using Webb's NIRSpec, near-infrared spectrograph. But it wasn't until March 2025 that scientists confirmed what had eluded them for decades. Webb had been directed at Neptune to study atmospheric motion. What it found was far more remarkable. Not only images of auroras, but a detailed infrared spectrum, a chemical fingerprint of Neptune's upper atmosphere. And one detail stood out, a sharp emission line at a specific infrared wavelength. It was the signature of a molecule called trihydrogen cation, or H3. H3 is a rare ion, made of 3 protons and 2 electrons. It forms only under special conditions, when charged particles crash into hydrogen-rich atmospheres. These collisions ionize the hydrogen, creating H3s, which then glows in the infrared. On Jupiter, Saturn, and Uranus, H3s has long been used to trace auroral activity. And now, Neptune joins the club. Lead researcher Dr. Henrik Mellin recalled the moment. It was so stunning, not just to see the auroras, but to see the clarity of the H3 signature. After decades of searching, it felt like solving a 30-year-old cosmic puzzle. Another expert, Dr. Heidi Hammel, praised Webb as the machine that succeeded where decades of ground-based observation had failed. With this single discovery, Neptune completed the auroral quartet. Jupiter's are intense and largely self-generated. Saturn's are milder and solar-driven. Uranus's are distorted by its extreme axial tilt, and Neptune's, now revealed, are soft, displaced glows requiring the most advanced tools to detect. More than just beautiful, these lights confirm the existence of a dynamic magnetosphere, a planetary shield once only theorized. And Webb's work is only beginning. The telescope will continue watching Neptune across the full 11-year solar cycle. By observing the planet as solar activity rises and falls, scientists hope to understand how stellar winds shape the auroral dance of this distant world. Every flicker is a clue. Perhaps a spike in solar wind pressure will brighten Neptune's auroras, or a period of solar calm will allow the planet's ionosphere to cool further. Each variation deepens our insight into planetary magnetism. We stand at the dawn of a new age in ice giant research, not through fleeting flybys, but through years of steady observation. Looking forward, the dream is clear. A dedicated orbiter, equipped with infrared cameras and particle detectors, navigating Neptune's magnetic field, capturing the auroras from within. As NASA plans a mission to Uranus, Neptune's turn may not be far behind. Webb's discovery makes the case. Future probes must carry instruments to continue this work. And when we eventually send one, we'll know exactly what to look for. The faint shimmer of H3, pulsing in Neptune's magnetic grip. Beyond Neptune, this discovery echoes further. Many known exoplanets are Neptune-sized. Some may have magnetic fields. Some may host auroras. If Neptune can produce auroras from such distant sunlight, perhaps exoplanets can too. One day, infrared telescopes like Webb might detect H3 or other auroral markers in alien atmospheres, revealing planetary magnetism across the stars. Neptune's shy auroras remind us that even in the farthest shadows of our solar system, light waits to be discovered. And our universe, which we thought we knew, still whispers mysteries, waiting for us to listen. The silent glow has spoken. Now we know where to look.